All right, today's video is going to be awesome. We are going to get to a point where you understand input actions, input mapping context, events, variables, line trace, blueprint interfaces, and blueprint inheritance. I had to look at a list there because there's a lot we're covering here. Now, let me just show you what the final result will be. You'll be able to walk around with your first person character and press interact, which will shoot out a line trace. Now, this line is visible just for development purposes, but what happens is if this hits an item, it's going to ask that item, hey, do you speak my language? Can you communicate with me? And in this case, the floor can't communicate. It doesn't have anything set up. But if it hits our custom blueprint objects here, like this box, for example, it'll say, yeah, I can communicate. And by the way, I have these objects, a pencil, scissors, candy bar, and bandages. You see that printed at the top left of the screen. We can go over to this sphere here and we can ask it, hey, do you interact with me? And then it'll say, yeah, I've got glasses, wallet, keys, and a toothbrush. Don't take this the wrong way. I don't care about this project that we're about to make. I don't care about your project, and you shouldn't either. What you should care about is not the final result, which is, kind of cool, but you should care about the concepts that you're going to learn and pick up along the way, because that's the whole purpose of this tutorial. What we're going to do is we're going to start a totally new first-person template, and I'm adding the first-person template just so that we can get some movement in there, the first-person movement. Okay, let's create it as a blueprint. We're not going to do C++, we're going to do visual scripting, and we don't need the starter content. Let's call it, I'm just going to leave mine my project 2. I don't really care. All right, create this new Unreal Engine first-person blueprint project. All right, now we're here, no surprises. Let's delete this gun model. We don't really need that. And everything else is fine as is. Let's go to the content drawer with Control Space, head to first person blueprints, and let's grab our BP first person character. Double click, it'll open up a new window. Let me just dock that on the top here so I can show you everything in one window. Now, what's important right now is paying attention to these little red nodes. These are called events. This is an event graph. So we have this event, which is our look event. And before that little look event, we have IA. That stands for input action. That's our first stop on this train of learning today. We're going to stop by this concept of input action and input mapping context. Let's go back to our first person map, hit Control+. Let's step out of the blueprints. Let's go to the first person folder, and we have another folder called inputs. Within that, we have these funny little things called IMC and a folder called actions. Now, IMC is just input mapping context. Under this folder called actions, we have IA, input actions. This is a fundamental principle in Unreal Engine. It's important that you understand this. An input action is simply just that. It's an action that you input. You can input it on a keyboard. You could input it through a gamepad. It's just an input action. Let's step back again. A IMC is an input mapping context. This is how we take those actions and we put them to use. We start to map out what they do and how they change on their way to interacting with the environment. Okay, so we have input actions. That's like the very, very building block. That's the first step. We have an action. It gets placed into a mapping context. And then from there, it gets carried into our first person blueprint. We start with this input action, and then the blueprint identifies what it's going to do within the engine. That's like very, very broad. Now let's actually start to break down how in the world Unreal Engine or Epic Games has started to build out some of these template options for this first person character. So let's go back, let's look again at the actions, and let's grab a very basic one, our input action jump. Just double click and you get this list of options here. The important thing is under the value type, we have what's called a bool. A bool or a boolean is simply true or false. In this case, it's on or off. For a jump input action, that makes sense. Either you are pressing spacebar or you're not. Either you're pressing A on your controller or you're not. This is a button and it's a digital bool. So let's look at a different example. Let's go back and look at input action look. This value type isn't a bool, but it's an axis, which makes sense. If we're looking, that's typically along different axes. I never know the plural of this. Axi, axes. It's looking in different directions. So that's why the value type here is axis 2D. Let's go back again. Let's look at another one. Let's look at move. Same thing, it's an axis, 2D. We're dealing with a range of numbers along a particular axis. So let's go ahead and exit out of our input actions and let's try adding our own input action. So I should say the long-term goal of this particular video is we want to build some brand new custom game functionality where our character walks up to something, it looks at an item, we press interact, it gets into the item and it finds out what items are in this particular item. So it could be like a box and we're going to go look inside the box and we're going to ask the game what's inside this box and the game's going to tell us. That's very useful functionality and we're going to learn some really, really crucial fundamentals along the way. So we have all the buttons we need to jump and look around and move already in the first person template, but we don't have an interact button or an interact input action. So let's go ahead and add that. Let's right click and under input, let's add a new input action. Let's call this IA for input action, just like these other ones, underscore interact. This is our input action interact. If we double click this, we can define the value type. Digital bool is fine. Either it's pressed or it's not pressed. We can add a trigger if we want, and we can look at some different triggers. Before we do this, let's just look at what the jump trigger was, for example. We go to jump, under triggers, we could see there's pressed and released. Okay, there's a trigger for when it's pressed and released. Let's go back to input action interact, and let's just look at some of these options here. We have pressed, we have down, we have hold. These are the main three that I would use. We can experiment in just a moment to show you visually what these would do. But for now, let's just use pressed. If you hover over pressed, it'll tell you. Trigger fires once only when input exceeds the actuation threshold. So all that is fancy language for saying when I press that button, it'll trigger one time. Okay, that's our input action. That's all there is to it. Let's save it. Let's exit out of all of these and we're good to go. We have our input action interact. Just remember the name of that. We called it interact. Now let's go back and let's go to our input mapping context. Under here, if we expand on mappings, we have some different mappings that do different things. Now buckle up because this is gonna be a little bit confusing when we get into moving around. But I want you to understand so that you can create your own character and tweak your own character movements as you need to. So we have an input action. An input action, in the case of jump, was a bool. It was on or off. That one's very simple. All we need to do is in this mapping context, we're mapping where that input action is happening. So we can add as many buttons as we want to this jump button, this input action jump. Right now, we've added it simply to spacebar and to the gamepad face button bottom, which if you have like an Xbox controller, that's the A button. All right, let's just for fun, let's delete those both and let's add them by, custom. Let's just custom add these in again. So let's add a new mapping. And for the mapping, let's select input action jump. That's what we had before. We can move it up even to where it was before. And now we identify the buttons that need to be pressed for this input action. If you just click the keyboard, you could just press a button. You just press spacebar, and now spacebar is mapped in the context to the jump input action. Let's add another one. And for this one, let's just press the A button on our gamepad, which is the gamepad face button bottom. All right, that's all we need to do here. We don't need to add any what are called modifiers, anything like that. We simply have spacebar and the A button on our gamepad, and that activates the jump input action. Now, there are 3 places that we're looking at right now. We looked at the input action. We're done with that. Don't forget about it, but we're done with that. Move past that. Now we're looking at the input mapping context. This is where we're assigning which buttons trigger the input action. The third part is in our blueprint. In this case, the blueprint first-person character. Now we're telling it to look out for these buttons, to look out for these input actions. How did we tell it to look out for it? Well, we added an event called event receive controller changed. And we're casting to the player controller. We're getting the enhanced input local player subsystem. All that's saying, this whole setup, the whole purpose is we're adding the mapping context. So this whole thing right here, input mapping context, all this is, and this will be the same every time you set up a character. So you can get familiar with these nodes, study it, look at it, understand what each of these does. What I'm telling you is all of this, all it is it's saying this blueprint first-person character should communicate with this input mapping context. It should recognize when things happen within this input mapping context. That's all that's happening here. You could tell it is grabbing the mapping context of the input mapping context underscore default. That's this one. That's now giving us the ability to input our buttons that we're identifying to change things in our character. What are we changing? Well, that's the third part of the system. We have these events. You can tell it's an event because it's this red little node. This one is our input action look, for example. Well, let's look at the jump just because we've been looking at that one. So we know when we press spacebar or A, then we are starting this jump action. And when it's completed, we're going to stop jumping. That's the simplest version of this that you can get. So let's compile, let's save. Nothing's changed really. Let's play our game. And when we press jump, we jump. All right, nothing crazy there. So let's continue on with our custom example. We have our jump input. We have our move input action. And this is where things get a little bit complicated. And the best way to help you understand what is going on is just to play around with this. So you might have a heart attack when you expand this for the first time. But we have a lot of different buttons that are doing a lot of the same stuff. We have WASD, that is forward, backwards, left, and right. We also have the up, down, right, left arrows on our keyboard. This is just kind of a backup. It's redundant, right? We already have W going forward, but also the up arrow on the keyboard can also control our player's position. We have another redundancy, or another option, which is the gamepad left thumbstick. So, as you know, if you play any games, the left thumbstick is often used for moving around and the right thumbstick is used for looking. That's how a gamepad works. And right now for move, we have all these options. Well, just to clean this up a little bit, I'm going to delete the up, down, right, left arrow because we already have WASD. So I'm just going to delete those. Just hit this little trash can icon. And I'm only going to focus on WASD. As we know, in this first-person game, W is forward, S is backwards, A is right, or sorry, A is left, D is right. We know that, but how do we tell the computer that? The computer doesn't know that. Well, we do that. As we expand this, you can see this tab called modifiers. So This is where things can get a little bit confusing, but once it clicks, it'll really click, and hopefully you'll understand this forever. When we input something, all of these are essentially doing the same function. All of these are moving the character. How do we know they're moving the character? Well, if we go to the blueprint and we look under input action move, we could see right away it is adding a movement input, okay? And it is getting the actor right vector, and it's getting the actor forward vector, and it's moving our character. That's essentially what our movement input is setting out to do. It takes the input action movement and it's doing all these things. Now, wait a minute. How is it only taking one trigger and moving forward, backward, left, and right? Wouldn't it need 4 different triggers? Well, we handle that within the input mapping context. Now, this is what I mean when I say every one of these buttons does the exact same thing. We just have different modifiers per button. So let me show you what I mean by that. Just as a baseline, let's do a quick test. We already know this works, but W moves forward, A moves left, D moves right, S moves back. That's as expected. We know that our character is moving correctly. Let's start to break this down a little bit. Let's go to W, for example. It's set up as a trigger. Our input action, the W key, is triggering our input action move. For the modifiers, under W, we have this funny little term called swizzle input axis values. Now, swizzle, all that means, I like to think of it like you ever been on a swivel chair, swizzle chair? What we're doing is all of these, again, do the exact same thing. Let me show you what they do by default. Let's get rid of this modifier. Let's just delete it, all right? So this W key has no modifiers. Now, if we save this, we go to our first person map and play, I'm gonna press the W key, which should take us forward, but look what happens. We press W and we go to the right. Every one of these buttons by default will send us to the character's right vector. It's sending us to the right. And that's what these modifiers are here to correct. So let's add back in that modifier, the swizzle input axis values. All that swizzle is, like a swivel chair, is it is moving our axis. It's swizzling to a different axis. So where we were going right, we've now swizzled that and we're going forward. That's one way we can change the 2D vector input for this particular mapping, okay? So we were going right when we pressed W. We added a swizzle input axis values modifier. Gosh, that sounds like a foreign language. And now we're going forward, okay? Let's save. Let's try this out. We've swizzled the value. Now I'm gonna press W. Good, we're going forward. But what about going backwards? Well, that's where we get our second modifier. We're only using 2 modifiers here, okay? So W is good to go. S moves backwards. How do we move backwards? Well, we know by default we're moving right, so we need to swizzle that, okay? So we added a swizzle input. If we go to modifiers, we added a swizzle input axis value. So now we're going forwards, but we added another modifier called negate, which will reverse the direction. So swizzle, negate. Now we're going backwards, okay? If you don't believe me, play around with this. You can get rid of negate. Let's just delete that for S. And now it has the same exact modifier setup as W. So what's gonna happen? I'm gonna press S right now, and we're gonna go forward. No surprises there because we got rid of the negate modifier. Let's go ahead and add that back in. Let's hit plus here, and let's search for negate. Funny language, swizzle, negate, these might be new words to you. But now we press S and we go backwards. Hopefully you've been able to guess by now what we do for the D key, for example. What does everything do by default? It goes right. What do we need to do to this? Absolutely nothing. What should we do to the A key? That needs to go the opposite direction of right, it needs to go left. Well, all we need to do is add a negate. We don't need to add a swizzle because we don't need to change the axis. We just need to go the opposite of the direction we're going by default. Now, I understand this is a lot, all right? I don't blame you if you need to watch this section a few times. Let me just put my phone on silent. But this is important. It's important to learn. Hopefully you only need to learn it once. And again, I could have just taken you through this and said, click on swizzle, click on negate, do this, do this, do this, and you wouldn't learn anything, and that's pointless. The point is to teach you so that you can create your own stuff, okay? So now we have WASD working. We also have the option for the gamepad left thumbstick, and this has its own modifiers. When we're dealing with a thumbstick, we have something called a scalar modifier, and this is basically just if we increase this or drop this down, we can see we have values for X, Y, and Z. This is just basically increasing you can think of like the sensitivity or the effectiveness of this particular input. So by default, they've added a scalar of 50-51. What that means is they're increasing the movement on X and Y by 50. And that's, I imagine, just so that we can walk left and right as fast as we can walk forward and backwards. To see this in effect, let's change this to 0 all around, just to show you what I'm talking about. Let's save. And now, doesn't matter, I can walk around with WASD, but if I try to use the left thumbstick on my gamepad, I can look around, but I cannot move because that scalar modifier was set to 0. So let's change that again. Let's set it back to what it was by default, now that you know what it does. And we're not going to mess with that one anymore. Now we also have what's called a dead zone. What's a dead zone? Well, let's get rid of it. That's the best way to find out what it's doing. Let's just delete it. Let's save this. Let's go to our first person map. And as soon as I touch the movement on our controller, I'm not touching this anymore. What's happening is my controller has what's called drift. It is not perfectly calibrated, and even though the thumbstick is not getting touched, it's starting to walk around the scene. How do we fix this? Well, we have a handy modifier that was already added called dead zone. And the order of modifiers does matter. Let's put dead zone back at the front or at the top. And you can see it has a lower and upper threshold. We don't need to mess with the upper threshold. We want to max that thing out if we want to run as fast as we can. But the lower threshold is set to 0.2 so that anything below 0.2 won't be recognized. It's a dead zone. It's not going to take that into account. And now if we save this, go to our first person map and press play, I can walk around with my controller without all of that annoying drift. And that's going to be the same. AI input action move was the most complex one. You can look through input action look, and it's going to be a lot of the same stuff. We have mouse input for looking around. We have some modifiers. All we have there is a negate modifier. If you expand that, it's only negating the y-axis. If you want to see what happens if you negate these other ones, go ahead and do that. It's basically going to invert your mouse direction, which could be like an option for some of your players if they want to invert it. Again, in the gamepad right thumbstick, we have some modifiers. Among those, or I guess the only one, is the dead zone. And again, that's so that we don't have that drift on our right thumbstick where we're looking around when we're not touching the thumbstick. Okay, that's everything. Congratulations. We looked at input actions. We added our own input action called interact. And now we've looked at input mapping contexts. So let's go ahead and add our input mapping context for interact. So let's collapse these. And just like we added with the jump, let's add a new input mapping. And for some reason that expanded jump and move, I don't know why. But now this new one, it's just called none. Let's assign this to input action interact. Now that we have that, let's expand this and let's just choose a button for interact. If you just click the keyboard, let's make E interact. And let's not let that be the only one. We want to include our gamepad as well. So we have E. Let's click on this and let's press X, or the gamepad face button left. Now, I don't need any modifiers on those. It's simply good enough to press the button, and that is our interact button. How do we test to see if this is working? Well, let's save this. Let's go to our Blueprint first person character. And just like we have these events that trigger all of the functionality we have with moving and looking, let's go ahead and add an event for our input action interact. So let's just right click and we can just simply type in input action IA underscore interact. And we get this little icon here, which is the right facing arrow in the diamond. And that is the icon for an event. So that's what we want. Now we have input action interact. When we press that button, this is the third part of the equation. First part was input actions. Second part was the input mapping context. Third part is the actual blueprint. This is the third part. What do we want to happen when we press E or X on the controller? Very simple for now. Let's just do what's called a print string. That's just a debugging tool. It's just for development. It says it right here, development only. And it's going to print a message. What's that message going to be? I just interacted. All right, let's expand this. We could choose the color of the message. Let's make it like green. And we can change the duration for how long it's on screen. Let's do 10 seconds, okay? Let's compile this. Let's save it. Let's go to our first person and play. And now when we press interact, it'll give us that message. I just interacted. Now you'll notice even if I hold it down, it's only going to give us that message once. This is what I was saying. We can start to play with some other things. Let's go ahead and go to our content drawer. Let's go to our actions. Let's go to our input action interact. And instead of this being a trigger when it's pressed, let's just change this to down. You can see the trigger fires when the input action exceeds the actuation threshold. That's some fancy language. Let's just test it out. Let's see what happens. We change it to down, and now whenever I press this button, as long as it is down, it is going to fire off a new action for every, I believe it's every frame that it's down. So very quickly we can send off hundreds and hundreds of input actions. That's not necessarily what I want. Oops. Let's go ahead and go back to that, and let's try to change it to something like hold. Now this will fire once input has remained actuated for a hold time. So naturally we can expand this and we get our hold time. Let's change this to 3. So now, if I'm understanding this correctly, this will not fire off an action until the button's been held down for 3 seconds. So ready? 1, 2, 3. Oh, give or take. I was a little bit fast. But now you can see it started firing that off after it had been held down for more than 3 seconds. Let's just change this back to pressed. That's all we need. Let's save, come back here, test it, and there you go. Now when we press our E key, our interact key that we identified in the input mapping context, it will fire off whatever functionality we have in the input action event, which right now is just to print a string. Hopefully, I've presented that in a way where you can grasp it. The best thing for you to do, play around with some things. You know, this is all, the good thing about templates is they have something set up, not so you can never touch it and just leave it, but it's nice to get in and start playing around with the aspects that you're familiar with now. So take some time, mess around with some settings within input actions, input mapping contexts, and your blueprint first-person character. Have some fun playing around. I'm gonna go grab some water and I'll be right back. All right, hang in there. I hope you're still with me. This is a lot, and this is intended, you know, you have the ability to go back and forth and pause and skip chapters, whatever you've got to do. But that covers our input actions, input mapping context, and how to get those into a blueprint. Now let's create a separate blueprint, which will be the object in our scene. Let's start talking about something called variables, and then let's set up a language for our main blueprint, our character blueprint, to speak, to communicate with our secondary blueprint, our container. With that language, let's have our first-person character speak to the container and ask it, what objects do you have? And the container will speak back and it'll say, I have these items. So that is the scope of this tutorial. That's the goal. Let's jump in and start getting that to work. So let me just compile and save, make sure everything's saved. And in our first person map, let's open up the content drawer, Control Space. Let's step back to the content, the top level. Let me right click and let me go to Blueprint and create a new Blueprint class. This will just be an actor. And we'll call this BP for Blueprint underscore, let's call it container. Now this is the container that will be in the world. Let's just drag it into the world. And right now it's totally empty. It has no object, it has no logic, no scripting, nothing. So let's start to add some of that. Let's double click the Blueprint container and let's go ahead and add a static mesh just so we can see it in the world. Let's go static mesh. And in that static mesh, let's just call that, I don't know, container. Well, let's get specific. Let's call it SM container, or static mesh container. Now we can identify what kind of static mesh is called on here. Before we do that, let's talk about our parent-child relationships with blueprints. It would be nice if we identified some parameters in a parent level blueprint that are inherited by children blueprints so we can have different types of containers. For example, let's say we have a parent class called container and the children class, we have different kinds of containers. We might have a box, we might have a locker, we might have a refrigerator. These are all different types of containers. And within each container, we might have different objects. So what do we need to identify in the parent container? What does not change? Well, the fact that it's a container, that doesn't really change. And the fact that it has items. So let's go ahead and start to identify items. On the parent or the child level, that's where we can start to identify things like, what does this container look like? What specific items does it have? Things like that. We're in the parent level. What do we need to identify? Well, we need to identify that this has items. It has the possibility to have items. Another way to look at that is something called variables. Let's go ahead and add our first variable, and let's call this variable items. And let's look at the variable type. Right now, the variable type, you can either set it here or over here. It's set to a Boolean. A Boolean is either true or false. There's only two options. It's on or it's off. There's a lot of ways to look at it. Right now, we don't necessarily want to set this as a Boolean. We want to set this to a list of items or a string, multiple strings. So let's set this to string. Now there are all sorts of variable types. There are integers, which is like a whole number. There are floats, which can be decimal point numbers. There are vectors, which is a series of multiple numbers, usually 3. They can identify things like XYZ, like 3D space, or RGB for colors. Now there are all sorts of variable types. Right now, let's just focus on string. If you want to learn more, you can hold down Control-Alt, and it'll tell you a string is a piece of text. How's that different from a name? A name is a piece of text that is used to identify something within the game. Comparing two names is much faster than comparing two strings, okay? How in the world does that differ from text? A text variable is used for localized text. You should use this if this text will ever be shown in the user so it can be translated to different languages. Now, that may still not give you any more clarity. For the sake of this tutorial, I'm going to use a string. You could use a name, you could use text, you could use a string. Those differences will become more apparent as you have actual use cases where you start to use them. For now, just know we have a lot of different variable types, and right now I'm going to use a string. Now, under default value, this is what the value is by default, obviously. And we can't set a default value because it is telling us to compile the blueprint first. It even said please. So how can we deny that? Let's go to compile. And now we can set the default value for items. But of course, this isn't just one item. We want items. We want a whole list, or what's also called an array. So over here, next to the variable type, right now this is set to single, so it's a single string. We could change this to array, compile again, and now we can add array elements. For this particular parent class of Blueprint, I don't want to identify the items. I just want to identify that we can have items. That's all we're doing here. So I'm not even going to type in items. Let's compile. Let's save. And let's take a deep breath and go back to our first person map. Now, all we have here is a Blueprint parent class, and it's empty. All it has is the possibility that it can have items. It can have an array of strings. It doesn't even have a static mesh that's identified to show us what this is visually. So let's right click and say create child blueprint class. Once we do that, it'll give us the name blueprint container underscore child. Let's just call this first one box. All right. And we can copy and paste box. And we can call this other one, I don't know what's another type of container. We'll call this one locker. Let's save. Save everything up. Okay. We're all saved. We're good to go. Now, Blueprint container box is inheriting certain things from its parent, the Blueprint container class. If we double click this, we could see we have space for the static mesh container. And believe it or not, we do have the space to place items in this variable, which we'll get to in the actual event graph. All right, for now, let's identify a static mesh for this object. For this one, let's just grab a cube. And if we zoom out, we can see that cube. Right now, it's going to be pretty big. If we compile and save this, just to check here. Yeah, it's huge. So let's go back to our container box. Let's hit R to scale, and let's just scale this down and place it on the floor. Compile, save. There we go. That's a little bit more reasonable. And let's go ahead and drop our locker down here. And let's expand our locker. We might need to open full blueprint editor because this doesn't have anything. And you can see it's inheriting things from the parent class. We just need to go to the viewport. Under static mesh container, let's choose, I don't know, let's just use a sphere. I know that doesn't look like a locker. You might have to use your imagination. We don't have actual objects in our game yet. We're just creating some functionality. I'm going to turn off snapping just to get this to sit right on the floor. Compile, save. And now we have two different types of containers. We have a box and we have our locker, cube and a sphere. This is where we can start to add some actual functionality now that we have some basic stuff set up. We have our, let's close our interact and let's close our input mapping context, input action, input mapping context. Let's close those. Now we just have our first person character, our container parent class, our container box, our container locker. What we can do with our children now is we can define which objects are inside of them. So let's go to the event graph. And, oh, let's see. We don't really have anything happening for the parent class. Let's delete all of these. And the children class, let's delete all these as well. Yeah. We're good. Okay. Compile and save, compile and save, compile and save. In our box child class, let's add a new event begin play. So when this is loaded into the game, let's set the items that it has. So let's go ahead and drag this out and let's say set array. Sorry, that's not right. What do we want to do? Let's get our items. Scroll down until we get to variables and we have get items. All right, and now we want to set our items. So when we start the game, when this is loaded into the game, we're getting the items, which is empty. We don't have any items, and we're setting the items. What are we going to set these items as? Well, let's just identify that now. Let's say the box has bandages and it has a candy bar, scissors. This is a strange assortment. And I don't know, a pencil. I'm not putting too much thought into this, obviously. Let's compile, let's save. Let's do the same thing with our container locker. Let's do a event begin play. Let's get our array. Or sorry, let's get items. Scroll down until we see the variable. And then let's set those items. When the game starts, this one in the locker will be a toothbrush. I shouldn't have added so many items, and I got to think of stuff. Keys, wallet, and glasses. Okay, let's save. Nothing is happening. All we've identified is which items are in each of these containers, but we have no way of getting in and finding out what these are. We could print them just to make sure. Let's do that, just to make sure the items are actually there. After we set the items, let's do a print string, and let's print, let's see. Now, we can't just print the items because there are multiple items. You could tell because there is this array icon with all of these items. Instead of just printing this into a string, which will not work, we need to print each item in a loop. So we get a for each loop. That's kind of like for each item, do this. So for each item, print the string. All right, so let's make sure this is all hooked up. Let's compile, let's save. Let's do the same thing for our other one. For each item, we are going to print a string. What is that string? It is each item in this array that we just set. And for the locker, let's make the text red. It's orangish red. And for the container, let's just keep the text blue. Both of them will just print very quickly and then disappear within 2 seconds. That's fine. Compile, save. Now, when we play the game, yep, it printed all of those items in red. You might have missed it. Let's play it one more time. Glasses, wallet, keys, toothbrush, pencil, scissors. It was only there for 2 seconds. But we know that everything has been set for each of these. Very easy. Let's just get rid of that print string. We don't need that. We know that it's working. We know that the items are set individually for each child container. Still with me? I hope so. We're covering a lot of ground, but let's continue on. Let's continue on with our functionality. So now we know there are objects in there, but now we want our character to be able to walk up to an object, press the interact button that we set up, and discover what objects are in each container. This is key functionality. It's going to take a few more steps, 2 more really big steps. The first step is we need to find out how to get these blueprints communicating with each other. Now, this is really, really important. This could be considered a beginner mistake. If you go to interact and you want to find out what's inside those objects, so you do something called a cast function. So we cast to blueprint underscore container box. So what a cast is it's what's called a hard reference. A hard reference is good in some cases. We had a hard reference up top here, for example. We are casting to the player controller. That means every time the Blueprint first-person character is loaded into the game, which is all the time because it's our character, it is casting to the player controller, which is loading the player controller into the Blueprint first-person character. In this case, that's great. We are never going to have a first-person character without needing the first-person character controller. We're just always going to need the controller. So creating a hard reference with a cast is totally acceptable. With our container, however, our box, it doesn't make sense to create a hard reference to this box every time we want to interact with it, because now that box, Blueprint container box specifically, is referenced in our Blueprint first-person character permanently. Whenever our character is in the scene, which is always because it's our character, it is also loading our container box into memory. Its variables, everything about it. It's in our game, loaded in all the time, whether we see it or not. That could mean there's a special box at the end of level 15, and it's loaded into our character when we show up for the tutorial at the beginning of the game. That's not very efficient. That's not how we want to do things. So cast to is effective for certain things when we want things to be hard referenced in a specific blueprint, and it's always going to exist in tandem with the other blueprint. That's not what we want here, so we're not even going to go down that path. Instead, what we need to talk about is something called a blueprint interface. What's a blueprint interface? You can think of it like a language, and instead of permanently coupling or connecting these two blueprints together, we can teach them each to speak our special language. And what can happen is our character blueprint can walk up to an item and it can say, hey, do you speak this language? Do you understand me? And the other item, our container in this case, yes, it understands. So it says, yep, I understand you. What do you need? And that's how we can start to get them communicating together. This is a simple concept, and it works really, really effectively, and it's going to expand on what you can actually accomplish in your games. So how do we create this language? Well, it's called a blueprint interface, and we just right-click, go to Blueprint, and create a blueprint interface. That's it. We can call this blueprint interface, BPI underscore, let's just call it interactable. So this is the language that every interactable object will speak in our game. And instead of loading every interactable object into our character permanently throughout the whole entire existence of our character, we could just teach multiple blueprints to speak this language so they could just talk to each other casually without being permanently connected. So now with this BPI interactable, we can double click this, just hit compile, we can close out of this function. We have this new function. We could call this, we don't have to name this, but we can name it something like, since this is an interactable, let's just call it interact. And that's literally all you need to do. Compile, save, close out of that. Let's forget about it for now. So we have that blueprint interface. Now we need to teach each blueprint to speak that language. So BP first person character, let's go to our character. Let's go to our class settings, our blueprint class. Let's just go to the settings, okay? Click on settings, and under implemented interfaces, right now we have no interfaces. We speak no languages. So under add, let's just type blueprint interface BPI, and it's already come up as the only option. BPI interactable. Now our blueprint character speaks interact. It speaks our language. That's perfect. That's all we need to do here. Let's compile, let's save, and let's go to our BP underscore container. Let's do the same thing. Class settings, implemented, let's see, implemented interfaces. Let's add BPI. interactable. Now our parent class, Blueprint Container, speaks interact. We can go to a child class, and because it's a child of the parent, it has inherited that language. It's already fluent. It's been speaking it since the day it was born. It speaks this interface language of interact. So now what we could do is at event begin play, we are setting the name of the items in this array. That's all we need to do. In the children, the items are being set in the array. We already went through that. In the parent class, now what we could do is let's right click this interact language and let's say implement event. And we get this little event with this Blueprint interface icon. And this is basically sitting here and it's waiting for something to speak interact to it. It's waiting for something to come up that's trying to use this Blueprint interface. And what do we want to do when something finds it and speaks its language? Well, let's go ahead and, well, to start, let's right click and let's just type in get items. Let's do the same thing. Let's get the items that are in this class. And for each item, for each loop, let's just print a string. And what's in that string? Whatever items are here. So the children should be inheriting this action from the parent. Let's compile, let's save, and there you go. When something approaches this container parent class and says, hey, do you speak this language? Do you speak this Blueprint interface? It'll say, yes, I actually do. Here are the items that are inside of me, and I'm going to print them. For now, we're just going to do a print string. In the future, you could do things like you can give those items to the player. We can communicate back and forth very easily. Now we have this interface. So let's go ahead and save. Let's go back to our first person map. Let me just save everything, make sure we're all saved up here. And let's start to add our final piece of the puzzle. I've put a lot of effort into this course, into this tutorial. I've made it free for you. And you can support me on patreon.com/RileyB3D. If I just have a few supporters, this isn't gonna work. I'm charging like $3 over there. I really want you to think, if at any point during this lesson you feel like, okay, Riley has given me $3 worth of value, then I encourage you to go check out my Patreon. I have a lot of perks there. We have a private, helpful Discord community that you can lean on to support you in your projects beyond this one. Then this channel has more of a future with the direction that it's going right now, where we have free information, there's no gatekeeping, but really, this is my plea, this is my self-promotion. It takes people actually thinking about supporting, and if the majority of people at least let that thought cross their mind and think, you know what, I did get $3 worth of value out of this tutorial, then go sign up. If at any point in the future you say, you know what, I'm not getting that value anymore, please just cancel. There will be no hard feelings. You can cancel at any point, but that's my sales pitch to you. We're going to continue on with the tutorial now, but I just had to say my piece. Please consider going over patreon.com/RileyB3D. That's the only way this can continue. I just need to be honest about that. Thank you. We have our interact button set up. Our blueprints speak the same language. They can interact with each other through a blueprint interface. Our containers are ready to say, to print what items are inside of them. Now, in our blueprint first-person character, we need to be able to ask those items, hey, do you have any items? Do you speak this language? What's going on? So let's go to our first-person character, and this is going to come off of the input action interact button that we set up earlier, the E key, all right? So what happens when we press the E key? Well, think about it. We need a way for our character to find an item in the world. There are a number of ways we could do that. One popular way is if we're overlapping with that item and we press the interact button, then we find out what's inside of it. Okay, I'm going to take it a step further, and we are going to use what's called a line trace. What a line trace is, it's very simple. What do you need to make a line? You need 2 points. So a line trace is just 2 points in 3D space. And any item that line hits, it can get information from that item. So we can identify 2 points in space. The first point should be our character, and it can shoot out from the first person camera. And once it shoots out, it can shoot out for a specified distance, and anything that it hits along the way, we're going to ask that object, do you speak our language? Do you speak our blueprint interface? Yes, tell me what items you have. That's all we want to do. So to start with that, what we need is a line trace. So simply right click and type in line trace. And for now, let's use a line trace by channel. So when we trigger this input action, interact button, we want to send out a line trace and tell us if it hit anything. Where do we want to start? Well, if we go to our viewport for our first person character, we have this camera. It's called first person camera. Let's go back to our event graph and let's use that first person camera. That's a good starting place because that's basically where we're looking from. So this could be our starting place, but we can't just plug that in because we need Unreal to figure out where in the world is the location of this first person camera. To get that, we just type in get world location. So now we are getting the world location of a target, and we're outputting a vector, 3 numbers, X, Y, Z. That tells us exactly in the world where this camera is. That's our starting point. It's as easy as that. Where's our ending point? Well, let's think about it. We need 2 things to figure out our ending point. If I have a starting point from my eyeballs here, we need 2 things. We need a direction, because I could be shooting out a line trace from any direction. So we need to know which way is straight, okay? We call that a forward vector. When we look at our viewport again, in our camera, we have a forward vector. It's this red arrow. How do we get that forward vector? Well, you type in get forward vector, all right? Once you have get forward vector, we need a second piece of information. We know where we're starting, we know where we want to shoot that line, but now we need to know how long that line needs to be. So this is where maybe this gets a little bit confusing, but try to stick with me on this. We could just plug this into the end, but that's not telling us a distance. That's not telling us how long the line should be. What we need to do is we need to take our starting point, which is right here, and we need to add. Let's go to operators, add. We need to add the direction, all right? That's a good starting point. So we know where we're starting for the endpoint, right here. The starting point's just the location of the camera. That one's easy. The endpoint, we're getting the location of the camera, and we're adding the direction that we want to be facing. But now we need the length. So what we could do very simply is let's drag out from the forward vector, and let's just use a multiply node. And let's plug that into the add. Now we could multiply by any number, and this will be the length of the line. But let's just make this a little bit more modular, so we can change that length at any time by making that length a variable. So let's add a new variable, and we can call it, I don't know, trace distance. This is the distance that we're going to trace. And this isn't an on or off Boolean. This could be a float, which is just a solid number. So let's compile, or sorry, not a float. Let's make this an integer. All right. What's this trace distance? Well, in Unreal, the unit is a centimeter, so let's say 300 centimeters. Compile, and now let's just grab this trace distance. Let's get the trace, which should be 300, and let's multiply it by the forward vector, add it to the starting point, and that's our end point. Is this going to work? We can test it out. Now, luckily, line trace by channel, it comes with some debug options. We can draw a line for one frame, for a specific duration, or persistent. If we set it to persistent, it'll never go away. It's just going to draw a line and we can study it forever. Some other options here, it has a trace color. Let me grab my trusty jar here. When we shoot the line trace, it's going to be red. It's a trace color. If it hits anything, it's going to change to a hit color, which will be green. So if it's a red line that changes into a green line, we can know that it hit something. And when we hit that item, that's where we're going to continue on after this in our out hit options. We're going to say, did you hit anything? Okay, what do we want to get from that item? We'll get to that in a second. But for now, let's just see if our line is working. So let's compile. Let's save. It's set to draw a line persistently, so it's never going to go away. Go to our first person map, play, and when we hit interact, it has drawn a line for 300 centimeters. That's the range of our interactable distance. You can see if we hit the corner over here, you can see after it hit it, it turned to that green line, which is saying, hey, I hit something, I have information, or I have the possibility to get information. Okay, you're doing so good. We're about to tie everything together. Let's go to our first person character. We have our interact set up. We have set up a line trace that's working. We can increase the distance. Let's set it to 400 just to be a little bit longer. So it was feeling kind of short. And what are we going to do after it's hit? Well, let's do what we always do when we're testing something. Let's print a string. What are we going to do on out hit? Well, we want to break the hit result. We're breaking it up into all of the information we could get out of that hit. So we're taking the hit from our line trace. And then if we expand this, we can see all of this information we could get from this. For now, let's just get the hit actor and feed that into the print string. It's going to do a little conversion here automatically, which is fine. Okay. What we're doing is when we hit something, we're telling it to print out the actor. We can test that. All right. Now, when let's see, for example, this floor is called static mesh _ cube. So if I play this now and I hit the floor, see that print screen? It says static mesh _ cube. So it told us what actor we hit. We could hit this blueprint. It'll say blueprint container box, blueprint locker. We can go around and we can identify different things that we're hitting just to see and make sure that this is working, which it is. That's perfect. But now we're tying it all together. We're going to put together everything we learned into one nice little package here. Let's get rid of our print string. On the hit, we're breaking it up into all the options that we can do. We're still going to use our hit actor, but what are we going to do? Let's ask the hit actor if it speaks our blueprint interface. And let's type in interact, and we get this BPI, blueprint interface interactable. That's our language. We have two options. If you choose the wrong one, you can just go back and choose the other one. We want to choose the one that says message because we're sending a message out there and we're seeing if anyone speaks our language. So again, if you choose this one, you'll just realize that you don't have a little blue tick here for the hit actor. So if that happens, just right click again and let's try interact. And this time let's get interact message. If you're not seeing interact message, you might need to uncheck context sensitive depending on what you're trying to pull from. But let's just grab interact message. We're sending out a message with what? What are we sending a message to? With whatever we hit. And we're asking it, do you speak Blueprint Interface Interactable? Do you speak my language? Okay. If it doesn't, no big deal. It's not going to do anything. If it doesn't speak the language, that's it. If it does speak the language, what's going to happen? Well, if it does speak the language, it's going to go through for each loop, and it's going to print a string for all the items that it has. In the children class, we've identified what those items are. Everything should be coming together now. Let's compile. Let's hit save. We've set up a custom button for the interactable. We've done a line trace. We've identified a language or a Blueprint interface that we can speak. We have our parent Blueprint container, which is going to print, if it speaks this language, which it does, it will print all the items that it has. And for each child class of this Blueprint, we've identified which items are there. Let's see if this works. Moment of truth. Let's save everything, hit play. I send a line out into space. I say, do you speak my language? No, the floor doesn't speak my language. Does this box speak my language? Yes, and it has pencil, scissors, and a candy bar. Let's increase the print string time here. Let's go to 20 seconds just so we can really see what's going on. Box, do you speak my language? Yes. What do you have? Pencil, scissors, candy bar, bandages. Great. Sphere, do you speak my language? Yeah. What do you have? I've got glasses, wallet, keys, toothbrush. Floor doesn't speak the language. These cubes don't speak the language. Now, hopefully you could see how powerful this is. Now, this project file, this doesn't matter, right? What's important isn't that you did the things that I did and pressed the buttons that I pressed. What's important is now you can go take these principles that hopefully you learned, and you can take them into your own creations, and you can start getting blueprints talking to each other. You can do a line trace to see if you get a hit in front of where your camera's facing. You can start to set up custom input actions. This is all just another part in Blueprint Fundamentals, Unreal Engine Fundamentals, as we're trying to build a good foundation together. Now, obviously, this takes some effort putting together this course. I would really, really appreciate it if you would head to patreon.com/RileyB3D. It's how I make a living if the majority of people decide, you know what, I got enough out of this particular lesson that I can throw $3 or $5 Riley's way. I would really appreciate it. That's my ultimate goal for this. Yeah, so thanks for checking this out. Hopefully you learned some good stuff. Thanks for sticking with it throughout the whole video. It's quite the accomplishment. And I'll see you in the next video. Let's roll the credits. Thank you to those who are currently subscribed to me on Patreon. Thanks.